Hello all and welcome back. So in this video, let us now complete our hash map implementation using open addressing, and now let's implement the delete functionality as well. Okay, so let's get started. So before moving forward, there was some things which we need to correct. Like there were a few typos which we made in our last implementation. What we did was we have used hash value here. Okay, instead it should be new hash value. So once I have found the new hash value, right? For example, let's say when we were starting at 1, now the new hash value is 2, then 3, then 4. So I should be saving at 4 this time, right? Not on 1 back. So we made a little typo. Along with that, of course, this else part was not handled. So we discussed that it should be a else part, but we were not able to handle it. Either we could have returned here, okay, or we should have handled it using the else block. Great. So now it's fine. And one more thing we can check out pretty quickly. We checked how that we were not able to get banana this time. And if I say apple, then also then it will be found, right? 10. If let's say I add another one here, so the capacity is 3. We are adding, let's say, pineapple here, right? With 30. If I try to find banana now, then it should say that, hey, I am not able to find, but because I have traversed full. So we wrote this error, right? Not found because it has traversed full. If I do this now, see, not found, traversed full. The reason is there was a capacity of 3 and I have added 3 elements into my overall hash map. Great. So now let us quickly implement the delete functionality as well, everyone. So let us start from here. We have done insert, we have done search overall, and now delete is left. So delete, I will be getting a self and I will be getting a key, right? Great. So the very first thing is going to be exactly same like this. We have to this time search and delete, right? So first I get the initial index and then I just save it in my current position. Okay. Then again, I will be writing a loop while self dot slots current position is not none, right? So till I'm not able to find none, what I have to do first, I have to check, have I found the key? Let's say if I ask you to delete apple here and you have found that, okay, apple is there. So your key is matching. So if self dot slots current position, it's equal to key, then what we have to do, everyone? We have to update to none, right? Self dot slots current position equals none. The state self dot values current position equals none. And we can maybe print here as well that print f key has been deleted. Great. And we can return from here, right? So that's the very first scenario, everyone. We found the key. If it is not the case, then we should make sure that we are moving forward in our current, right? So current position, right? So there should be current position only, not the key this time. And if by any chance I reach to the position I started with, so if my current position equals to the initial index, then also I should return, or rather break from the loop this time, not return. If we break from this loop this time, okay, then what we have to do, everyone? Print. See, if we are not, if we got a none, or if we are breaking, if we have gone the full circle, then key is not found. Okay, so let me now explain this, everyone. What exactly is going to happen? See, there are multiple cases. First one is you said that, hey, delete apple. I found apple here only. I go, I'm able to find it, I delete it. You said, hey, delete orange. I first go here. I said that, okay, it is apple, it is not orange. Increase by 1, do linear probing. It is banana, not orange. Increase by 1. Now it is orange. Now I delete it, right? One scenario is that if you get a none, just like search, none should not occur because in linear probing, we are not jumping from any particular uh, position, right? One more scenario is there, like let's say I ask you to delete pineapple. Let's say this is your whole array, just 3 size. You go here, then back, and you see that, hey, I have come back to the initial position, the one where I started. That means I have gone full circle on my both on my keys or the slots list. and I have not found the key which you were looking for. That also means that we don't have that key present, right, everyone? So let us try to run this now. Great. So let me just close this key. Then it's fine. Great. So let us try to now h1 dot delete. Let me try to delete apple. Let us try to get apple before deleting, and let us try to get apple after deleting. Okay. So just to see how it will happen here. So let us delete 117. I think it will be exactly the same way. It's a little long overall slots, so we cannot have where it is full. But if I ask to delete 117, it's first going to this, then linear probing, then linear probing, then linear probing, and deleted. So it's this case where after getting the new key, after just moving our current position, we will finally find the key. Okay. I think if I will not, if I will just send anything which is not present here, let me remove the just, no, it will stop at none, right? So let's say if I add 112, sorry, 112 in find. So it will stop at none. So this is not found, right? Because the hash value overall is something. Let us pass 117 only and now try to find it. See, it is 1, so it comes here. Next, next. Now it sees that is none, right? Okay, it is getting deleted here. We can make it none only. Great. So yeah, that's the overall working, everyone. Pretty sure that it should be clear. We will be going to the particular index. I've explained it from there as well as using visualization, right? So now what we are doing, we are adding apple, orange, pineapple. I'm getting apple first. We should get 10. Then we are deleting it. And then again, I'm getting the apple. See, 10, apple has been deleted and thus it is not found. Okay, so it seems like it is working absolutely well, everyone. Now, one thing which I would like, or rather two, three more functionalities which I would like in my hash map is something through which I can add like this. Just the way we do in our dictionary, right? So let us quickly implement them as well. They are pretty easy to implement, honestly. So this is a magic function. Okay, so let me just implement it here, everyone. See, to set. Okay, so when we say in our dictionary, let us see the working here. D1, let's say, is a empty dictionary. Okay, when I said D1 of apple equals 20, internally there is a set item. That's a magic function. Okay, in oops, we must have learned about them under underscore set item in Python. So let us try to see this, everyone. Set and get item. So let us see the first link. Set item. How has it been defined? Okay, getter and setter. Indexing attributes. Yeah, see. These methods are used only in indexed attributes. So when you pass array of 0, this is where this set item or get item is getting used. Okay, so some other place where we can see the same. So has something been explained here using this bracket notation, right? This is where we are changing it, this set item and get item. So let us try to just implement it and check it. What we will be doing, everyone, in the set item, right? Again, I will be getting a key and a value, self, key, value. I just have to make sure that I return self dot insert with key and value. Okay. Similarly, get item, I will be getting just the key, right? So when we insert, we are sending two things. This is the value, this is the key. But when I ask, when I get item, I just pass the key. If we run this, okay, sorry, my bad. It is not a list. This error should be removed. See, everyone. Mm, yeah, so I'm able to get it. See, this is set item, set item. I am sending key and value here, right? And this is get item, sending just the key here. If I'm sending just the key, what can I do? Again, return self dot get just the key, and it's going to work. That easy. Okay, great. The last thing which I would like to add the functionality for is to print my overall dictionary. Okay, just like we are able to print our dictionary in our using our print dictionary function. So for example, here if we do it, print d1, right? If I do this, then I get this apple and 20. Okay. Here what we can do, if let's say it is print h1, we will be seeing some overall address or something. See, hash map object. It doesn't know how to print it. This can again be very well handled with a under underscore str function. So these are the things which you must have studied in OOPS, right? When we call print, internally str gets called. How can I prove it? See, I am here. If I've written this code, I am here. And if I run this, what's the error it's saying? Okay, it is saying that it's returning none. So let us return something. See, it is saying I am here. Okay, so something which we must have studied in our OOPS concepts. To execute the printing overall, what we can do, let's say we create a result, which is a empty list maybe. Now for I in range, I am going to full capacity. Okay, so each and every slot I'm going to check. So self dot slots of I. If it is not none, that means that something is present there. And if something is present there, then what I can do? Result dot append. Okay, I am just appending. Say we can append a string or something. There, what I'm gonna do first is, let's say, your I, which is your key, everyone, and then we can have self not key. I will not be the key. Self dot slots of I. Okay, so this is my key, and I can have self dot slot. Sorry, self dot values of I. So this is my key. Actually, let me use it. It's I in range self capacity. Okay, so self dot slot is this. Okay, I is actually a range, a number. So I'm just using slot this particular key, right? If I close this now and add another one here. Great. So I'm just adding a string. Okay, everyone, which is in the form of this particular thing. So it is the key and this is the value. I'm using indexing here, right? So I is just a number which is helping me index. If it is not none, then we have to do this. Else, we can say, actually, we have to do nothing if it is not there, right? So now we can just return, and let's say I'm returning the result. Okay. So let us try to print this now, everyone. Okay, what's the error it is giving? Result append unsupported format passed to set dot format. Okay, let us just check it. Where have we made the error? If self dot slots is not none, right? Then I'm saying that hey, result dot append, result is a string. Just append this particular thing. It's a okay, we have I think messed up these things, right? Great. Now I think it should work. String return non-string type. My bad. Let us just return the string type. So for that, what I can do, let me just append it. Okay. Let me just join the result. And let us see this now, everyone. I'm able to get pineapple 30, orange 20. Okay. Again, we can make it beautiful. That is not the concern. I've just appended this because when you're printing something, we have to make sure that we are changing it into a string. So it should return a string. Either we can print it here only, or we have to make sure that we are returning something which is a string. So cool. I hope everyone this is clear as well. These are the major functions which we have to do. Now just to check it out, one thing what we can do, let us just use this one. So h1 of orange equals 45. Print h1 of orange. Okay. So now let us see what's going to happen, everyone. Let me just get rid of these things. I'm adding an orange this time using this rotation. and then I'm printing the orange. So I'm able to get 45, which means that it is working. The reason is that internally, just when you're calling this set item, when you're making this particular syntax, set item is just getting called. Similarly for get item, and we have written proper functions for them so that it will work. Okay. So great, everyone. Again, we'll just request that you try it out once again at your end. The code of HashMap, unfortunately, is a little complex. The same is going to get increased when we go to chaining. When we write the implementation of HashMap using chaining, that's a little bit more complex, right? So no worries, we are going to understand it properly with visualization and everything. For the time being, please make sure that you just write this code at your end once, right? See the video, start from a clean file and try to write on what all you have learned. And believe me, you will have a lots of confidence there. Okay. So great, everyone. Let's meet in the next video.